lipids. So we have said lipids are groups of naturally occurring esters or fatty acids and alcohols. So we have got different types of lipids, and we're going to start looking at them one by one as we mentioned. So the first one we should understand is a fatty acid. Okay, this is an example of a lipid, a fatty acid. So you need to know what a fatty acid is. Okay, so a fatty acid is made up of like hydrocarbons, a lot of hydrocarbons. So it is a type of lipid that is made up of a hydrocarbon chain. Now it terminates at the end of this chain. We are going to have a carboxylic acid functional group. Like you can even hear the word fatty acid. So like you have got a lot of carbons. Now when you have got this, let me just show you. You've got this carbon bonded to this carbon, bonded to this carbon, bonded to this carbon. Now each carbon should have 4 bonds, meaning that you are going to have hydrogen here, hydrogen here, hydrogen here, making these bonds 4. There should be 4 bonds for each carbon. Okay, meaning that even this one is going to, I'm going to put now anything like this will become hydrogens like this. Okay, even this will be hydrogen and hydrogen. You can see each one has got 4 bonds. So each carbon is supposed to have 4 bonds. That means that if I've got a double bond, let's say I've got a double bond here, this carbon already has 3 bonds. 1, 2, 3. That means that the other bond that is remaining, that obviously should be an hydrogen. And then this carbon already has got 2 bonds. That means it needs uh, if it has another carbon on this side, that means it has got already 2 bonds here plus this one 3. It only needs another 1 bond, and obviously that other 1 bond should be an hydrogen. Okay, like this. And then now at the end you are going to have this functional group, the C double bonded to O and then OH. This is a functional group. This is the carboxylic functional group. Okay, so that is how you see fatty acids. So when you are writing this now, representing it, because these are very long chains, this is a waste of time. So we're going to use a skeletal formula. So at every carbon I'll put this. Okay, at every carbon first I'll write a dot. So how many carbons do we have here? 1, 2, 3, 4, 5 and 6. So the way I'm going to write this is I'm going to be writing a zigzag starting from here. This will be carbon 1. At every corner there's a carbon, so that will be carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So this is the same thing, but at the end remember we've got uh, an oxygen double bonded to that carbon. So this last carbon we have got an oxygen, and then we have got an OH. So we are going to see this molecule bonded like this. But remember, when you are counting now, when you are counting these carbons, you always start with the carbon having the functional group. So it will be carbon 1, this carbon 2, this carbon 3, this carbon 4, this is carbon 5, this is carbon 6. Meaning that here we're going to have carbon 1 here, carbon 2 here, carbon 3 here, carbon 4 here, carbon 5 here, carbon 6 here. You don't show hydrogens when you are using the skeletal formula. Okay, apart from the hydrogens which are outside the carbon to carbon long chain. Now you can see that between carbon 3 and carbon 2 we have got a double bond. So I'm supposed to put another line like this, meaning that we have got a double bond between those carbons. Yes. So you are mostly going to see they've written a zigzag formula. Now don't call it like zigzag. That is called a skeletal formula. The reason is because it's like it is a waste of time using this for you to write the carbons, the hydrogen and everything else. So when you're using the skeletal formula, it is much easier. Okay, so this is how a fatty acid is going to look like. Now I'm not saying this thing, the exact same thing you are saying here, but this is how it looks like. You are going to have a lot of carbons bonded to hydrogens, and at the end of the chain you are supposed to have this. Okay, now that you have understood, a fatty acid should have a chain of hydrocarbons. At the end you have got a carboxylic functional group. All right, so because of this, because of the way you have just seen this chain, the way you have seen this chain, okay, let me do this. The way you're able to see this chain, these are a lot of carbons and hydrogens bonded together. This makes this, we call it the tail, because it has got carbons and hydrogen. Remember, those bonds are what? Those bonds are non-polar. So the tail is hydrophobic. Okay, the tail is hydrophobic. Now, if you look at the head has got carbon bonded to oxygen, and the bond between carbon and oxygen is polar. That makes this head to be what? Hydrophilic. It means it loves water. It can form hydrogen bonds. So that would be hydrophilic. Now, a molecule that is both hydrophobic and hydrophilic is called, who knows the name? A molecule both hydrophobic and hydrophilic. So this makes a fatty acid to be amphipathic. Okay, it is amphipathic. So the spelling I've seen it varies. In some books you'll see this. In some books you are going to see this. In some books you are going to see something like this. Amphipathic. Okay, it doesn't matter. So it is amphipathic, meaning it is both hydrophobic and hydrophilic. So that is how a fatty acid is. It is both hydrophobic and hydrophilic. So we call it amphipathic, meaning it can interact with water, and there's also another portion that cannot interact with the water. Now we have got two forms of fatty acids. We have got those which are saturated and those which are unsaturated. Okay, let's start with the saturated fatty acid. Now I know we know what the word saturated means because we did this in high school organic chemistry. Something that is saturated means it's more like enough. You can think of that. Okay, if you've got a carbon bonded to four different things, this carbon is called a saturated carbon. Why? Because there's no space for it to react. If you make, let's say, sugar and water, you make a solution. Okay, now you've put enough sugar such that it is so sweet, you call that a saturated solution. In other words, there is no room for you to add more sugar, because if you add more sugar, that sugar you're going to be adding will not dissolve because you've already added enough. So such a solution is called a saturated solution. So if you say a saturated fatty acid, it means it's a fatty acid that only contains carbon to carbon single bonds. There is no double bond within this chain. Okay, there is no double bond within this chain. We call it saturated because it is unreactive. It is unreactive, like all the carbon is already bonded to four different things. It cannot react, so it is unreactive. That is a saturated fatty acid. Now when you're talking about a saturated fatty acid, please, every time you hear of saturated fatty acid, you need, what should come to your mind is an example of a saturated fatty acid is stearic acid. Please, this one should always come to your mind. So stearic acid is a saturated fatty acid which contains 18 carbons. It contains 18 carbons. So we can draw it. We can draw it. So carbon number 1 here, number 2, number 3, number 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is how it is. And then at the end, you're supposed to have the functional group that bonded to an oxygen, and then you have an OH like that. So this is stearic acid. It has got 18 carbons and it is a saturated fatty acid because it has no double bond. All right. So the formula, you can also write it like this. If you consider this first carbon here, okay, it's supposed to be bonded to four different things. Now it already has one bond this side, meaning that it is going to have three hydrogens. So I'm going to write it as CH3, and then all these carbons, since this carbon which is here, it has got a bond this side and a bond this side, meaning that it needs only two more hydrogens. So the rest of the carbons which are in the middle here, and how many are they? 16 of them. Okay, starting from this carbon which is here up to this carbon which is here. Don't include this one having the functional group. They are all going to have two hydrogens. So I'm going to write it as C H2, and then we're going to put a 16. So they're going to have the carbon with two hydrogens are going to be the 16 of them, and then we're going to have this carbon which has a COOH. So this is the formula for steric acid. CH3, CH2, 16, COOH. Okay, that is steric acid. Now, because steric acid uh, is saturated, meaning it doesn't have any double bond. In other words, it is unreactive, right? It is unreactive, right? So, because it is unreactive, it doesn't have any double bond, you expect steric acid to be waxy. In other words, it should be a solid, okay, because it is not reactive. So this thing is a solid at room temperature and pressure. Please, you need to know this. Steric acid is solid at room temperature and pressure. So in other words, it is a wax. It's like candle. Okay, it is wax at room temperature and pressure. What explains that is because of it having saturated hydrocarbons. Okay, that is what explains that. So the absence of double bonds makes saturated hydrocarbons rigid. In other words, they are strong. Like they don't have any chance of them doing what? They don't have any chance of them reacting. So the absence of any double bonds makes them rigid. That is why they are what? They are solids at room temperature. Examples of saturated fatty acids apart from steric acid, you have got you can think of butter. Okay, you think of cheese, you think of coconut, okay, coconut oil, you think of margarine. So coconut oil obviously should be solid at room temperature, okay. You also think of fried foods, the oil is going to be like solid. So these are examples of saturated fatty acids. Just know that because there is no double bond, the structure is solid, it is rigid. That makes them also solids. So these are examples. Do you have a question on this one? Any question? Is it clear? Is it clear? All right. So I've mentioned this example that you always need to know, steric acid. At times they'll come a question in multiple choice. The following uh, let's say let's say the following lipids, except instead of putting a common lipid that you know, they're going to put steric acid. So you might not know. Oh, just know steric acid is a lipid, and it is specifically a fatty acid which is saturated. Now, steric acid is mainly used in the production of detergents such as soap and cosmetics such as shampoo, that thing that we use for the hair, okay, and also like cream products, like those things for cream, you like, especially for you girls who like is it atukoche mishishi, getting to, I don't know how you can call that. So like cream, shampoo, soaps, that is where the steric acid comes from. Like you can think of that, those are solids, right? Okay, another example of a fatty acid, another type, we talked of a saturated, we also have the unsaturated fatty acid. Now, the unsaturated fatty acid is supposed to be, since you can hear the word unsaturated, that should tell you that there is a presence of at least a double bond. So this double bond is what makes this unsaturated fatty acid being flexible. You need to know that unsaturated fatty acids are flexible. Okay, they are flexible. Please, you need to know that. Why are they flexible? Because they have got the presence of a double bond, all right, in them. Yes, Martha. You don't have any double bond apart from the double bond that you're going to see between the carbon and hydrogen. But what makes this, the reason as why we are calling this as unsaturated, you are talking about the bonds between carbon and carbon. You shall never find the double bond for the for the saturated, but for the unsaturated you have got a double bond. So okay. Okay, again, whenever you hear of unsaturated fatty acid, what should come in your mind is uric acid. Uric acid. And this one is very easy to know because think of oil. Unsaturated fatty acids are liquids at room temperature. Okay, why are they liquids? Because they are flexible. In other words, you have got a carbon now bonded to a carbon, right? That means that this carbon already has got two bonds. For it to be stable, it only needs two more bonds, right? So it has got this bond here and this bond here. Even this one is going to have a bond here and a bond here. So because of this, these unsaturated fatty acids, you just need to know that these are actually, this what I've drawn here is an alkene. You need to know that alkenes, I think from high school, you know that they undergo addition reactions. So you can react this with a hydrogen molecule. What happens when you react this with a hydrogen molecule? One hydrogen is going to attach here, another hydrogen is going to attach here. When that happens, this bond is going to be broken. It will no longer be a double bond. It now becomes a single bond, okay? So because of this, these are flexible because you can break that double bond and attach other substances there. When you do that, now they are going to become saturated. So unsaturated fatty acids, you can react them with hydrogen to make them saturated. A common example is uric acid. All right, now uric acid is also a unsaturated fatty acid. It contains also 18, just like the other one. It also contained 18 carbons. Even this one contains 18 carbons. Okay, so this one now, it has got a double bond. It has got a double bond somewhere, right? It has got a double bond somewhere, that is like on the middle of the chain. Let's draw it. Since it has got 18 carbons, carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then the last carbon supposed to have the functional group there. Okay, this one. Now you are going to count the eighth carbon. On the eighth carbon, which is bonding like to the ninth carbon, are going to find the double bond. Now I'm talking of starting from this side. Otherwise, when you are counting the carbons, you always start from the carbon which is near the functional group. Now I just want us to be quick. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is going to be 9. Please, you don't number from this side. I'm saying I'm only starting from that side so that it will be quick. So at this point, you have got a double bond. You have got a double bond there. So you can also write this in short form. You can see this first carbon, of course, is supposed to have 3 carbons because it only has one bond, which is here. It needs 3 more bonds. So I'm going to write as CH3. And then how many carbons do you have before the double bond? You have got this carbon 1, 2, 3, 4, 5, 6. You have got 7. Okay, you have got 7. So I'm going to write this as CH2, and then you are going to have a 7 there. All right, now please take note, this carbon which is here, it already has one bond, 2 bonds, 3 bonds, meaning that it is only going to have what? It's only going to have one hydrogen. That means that I've placed this bond at a wrong position. I've placed it at a wrong position. Okay, supposed to be then here. So it's supposed to be CH2 7, meaning that 1, 2, 3, 4, 5, 6, 7. This first 7, not first 7, apart from this other one which is I've already written here. These other 7, they're going to have a carbon with 2 hydrogens. Okay, that is how I'm supposed to write it. That's the correct one. And then now you are going to see a double bond. You are going to see a double bond. There's a double bond here. You can see, right? You can see this is a double bond. And then you are going to have, now before that double bond, notice that we have got, I only counted from here up to here, right? That is where the 7 was. 2, 3, 4, 5, 6, and then 7. Okay, now we have got this double bond which is here. So there is this carbon, it only has how many hydrogen? It only has one hydrogen. So we're going to write that as C and H. Okay, and then it is double bonded. There's also this carbon which has only a one hydrogen. And then you're going to have these 1, 2, 3, 4, 5, 6, 7. You also have other 7 carbons which have what? A carbon with 2 hydrogens. So we're also going to write now that as CH2. There are the 7 of them, CH2. And then you have got a carbon at the end with this functional group. So this is the formula for oleic acid. This is the formula for oleic acid. Now what I want you to know is that oleic acid has got one. Actually, this is an exam question. They are going to say unsaturated fatty acids have got 2 double bonds, 3 double bonds, 1 double bond, and those things. It has got only one double bond. Only one double bond. Please know that, please. Okay, so that's the formula for oleic acid. Now what else do we need to understand about oleic acid, or even just unsaturated fatty acids? So unsaturated fatty acids, we've said they are liquids. Okay, they are liquids. So because of course they can be like a bit of solid, but they easily melt at room temperature. That is why you are going to mostly find them as liquids. A very good example, you can even hear oleic. So this is what helps me even to know that unsaturated acid, an example is oleic acid. Like you think of oil. Oil is liquid, right? Oil is liquid. So examples of unsaturated fatty acids that you are going to understand is oil. Okay, you think of also like sunflower oil, just anything, soybeans oil, avocado oil, olive oil, just oil generally. Those are unsaturated fatty acids.